In this tutorial, I'm going to go over all 20 problems from exam 1 which you took today. Problem 1 has to do with vectors. Vector 1, which is 4 meter long, and vector 2, which is unknown. So you have to use the ruler to measure it. How many centimeters this one? If you do use the ruler, and ruler is going to give you 4.5 centimeters. You place the ruler over here, and ruler is going to give you 3 centimeters. This is almost 3, 4, 5, but not quite. It's not 3, 4, 5 because this was not 4. Okay. But what do you expect? This one, when you construct the displacement is from beginning to end. The shortest distance between 2 points, initial and final, is the displacement. Okay. So this is the displacement. So if this is 3, but this was 4, then this would be 5. But that's not quite 5. So I'm not sure what it is. So you're going to put the ruler, and ruler going to give you 5.5 centimeters. Okay. That's not what I want. I want you to write the final answer in SI units. So you're going to write 5.5 centimeter times centimeter and meter. Okay. So 1 centimeter is how many meters? You don't know. So you have to find it out, figure it out. So this is your main information. 4 meter is equal to 4.5 centimeters. So divide both sides by 4.5. So 1 centimeter is 0.89 meter. Okay, 1 centimeter is 0.89 meter. Okay, 5.5 times 0.89 is 4 centimeter cancel, 4.8 meter. So the answer is this one is 4.8 meter. Next time I'm going to ask you the exam number 2 on Friday. I'm going to ask you to use your protractor to find the angle between x-axis and resultant. This angle you're going to find. So come Tuesday, you're going to remind me to do this as a do now activity in the class. Make sure you bring protractor so we can practice it in the class, so that Friday when I ask you to find the angle, you would be able to find the angle quickly. That takes us to problem number 2. This is a very technical problem, so I want you to pay attention, because next test number 2, I'm going to repeat this question, but a little bit technical way. So this is exactly how I'll give it to you. So let's say kinematics. I'm going to remind you. So problem number 2. So kinematics is a study of kinematics. Describe motion using 5 properties. Number 1, distance. Number 2, displacement. Number 3, speed. Number 4, velocity. Number 5, acceleration. These all are derived quantity. Based on 2 fundamental quantities, 2 base or fundamental quantities: length and time. How? Distance and displacement comes from length. On the other hand, speed and velocity come from length over time, and acceleration comes from length over time. Okay, so what is the fundamental quantity? Fundamental quantities are the base quantities which you cannot express any other way. but the derived quantity need at least two fundamental quantities. For example, velocity, you need at least two fundamental quantities. You have distance, displacement, and time. Speed, you need at least two fundamental quantities. You need distance, length and time. And the acceleration, you need also two fundamental quantities. You need length and time you use time twice. Okay, great. So let's see length. What is the SI unit for the length? SI unit for the length is meter. SI unit for the length is meter. SI unit for the time is second. So you use fundamental quantities twice. You use two fundamental quantities for the derived quantity, which we call a speed, and the velocity, same thing. The differences between distance and displacement: the distance is a scalar quantity, displacement is a vector quantity. The differences between speed and velocity: the speed is a scalar quantity, velocity is a vector quantity, and acceleration is a vector quantity as well. So now all of them are derived quantity. Why is that? Because they all come from base quantity, and that is length and time. So please understand these technical differences. The answer for this question is, of course, meter over second, is because in a meter over second is which could be speed or velocity. Both cases they are derived. Why? Because you have to use a fundamental quantity twice. Question number 3 is related to question number 2. In question 3, I ask you a very simple to map 7 fundamental quantities with their SI unit. So this is 7 base quantity. I'll write base quantity, base quantity. All right. So and their SI unit, and I'm gonna first write them. First, I'm gonna write, of course, length. Number 2, I'm gonna write time. I'll try to write it in terms of the way I give you in the exam. Mass. Number 4, temperature. Number 5, current. Number 6, luminous. Intensity. Number 7, amount of substance. Okay, so I ask you to map to find the corresponding SI unit. So the length is meter, time is second, mass is kilogram, temperature is Kelvin, current is ampere, luminous intensity is candela, amount of substance is mole. Okay, so you see that problem 2 and 3 are connected. Problem 4 is connected to problem 2 and 3 because, again, I'm trying to understand your understanding on vector and scalar. So here's what I wrote: vector to scalar. So this is what I wrote: S to displacement to displacement to S to VD. All right, this is exactly what I gave you. This is 1, this is 2, this is 3, this is 4. Notice vector to scalar. This is scalar to vector. No good, because speed to velocity. So speed is a scalar, velocity is a vector. No good. This is vector vector, because velocity is also vector. No good. This is scalar, speed is a scalar, distance is a scalar. No good. Displacement is a vector, distance is a scalar. So this is correct, and that is problem 4. Problem 5, many of you got it wrong. I don't know why. On your reference table, I see something 10 raised to negative 1. 10 raised to negative 1, you can write many different ways. One way of writing it is 1 over 10. 10 raised to negative 1 is not 10. 10 raised to negative 1 is not 10 raised to 1. No, 10 raised to negative 1 is 1 over 10. Okay, and that's exactly what I asked you. Problem number 5 is, which one is the SI unit for a derived quantity? Okay, so I give you meter times second, and I give you meter times this one. Meter times second is meter second. There is no physical quantity in the universe whose SI unit is meter times second. None. However, there is a SI unit in the universe. There is a SI unit in the universe of a physical quantity which is meter over second. So meter over second is the SI unit for speed or velocity, which is a derived quantity. Okay, so you can write meter and you can write second is 1 over second. So you can write meter over second, which is the SI unit for speed or velocity. All right, so whenever you are not sure what does that mean, that means the power. If power is positive, then it's go up, number go up. If power is negative, then number go down. If power is positive, you multiply by 10. If power is negative, you divide by 10. Okay, if power is positive, then is go up. If power is negative, then is go down, is you divide. Okay, so s raised to negative 1 is 1 over s, as simple as that. However, s squared is s times s negative 2 is 1 over s times s. 6, 7, 8 are the same problem. It shouldn't take more than 1 minute or maybe 2 minutes to solve 6, 7, and 8 because you seen them the day before yesterday. So very simple. 6, 7, and 8. 6, 7, and 8. So I give you something like this, and this is called VT graph. All you need to do, know 2 points, right? This is 6, this is 15, and this is 10. The problem number 6, I ask you to find average velocity. Average velocity is, I'll do it here. Average velocity is Vf plus Vi over 2. Vf is between, of course, between 0 to 6 seconds. I ask you to find the average velocity. At 6 second velocity is 15. At 0 second velocity is 0. So 7.5 meter per second. Now let's do 7. This is 6. 7, I ask you a very simple question. What is the acceleration from 0 to 1 second? Right? So it doesn't matter since this is a diagonal line. This first degree polynomial, the slope is same. The slope at every single point is same. So it doesn't matter. I'm not going to spend time to find the slope between 0 to 1, knowing that every single point between 0 to 6 should be the same because this is linear. So I'm going to write acceleration is Vf minus Vi, Tf minus Ti. So Vf is 15 minus 0, and delta T is 6. 6 minus 0 is 6. So 2.5 meter per second is squared. Number 8, I ask you to find the displacement. You know, this one is half BH and this one is BH because this is a triangle, this is a rectangle. So this is half BH. Half B is 6 and H is 15 plus B is 10 minus 6 and H is 15. So this is 45 plus 60. This is 105 meter. Okay, so 6, 7, and 8 should take you 1 or 2 minutes. Number 9, based on one of the homework that I gave you, remember Isaac and Raf at Brown University, I asked them what would be the height between the floor and ceiling, and uh, I'm not sure what they said, but they got it wrong, and so we corrected them. But here there is no way you can get it wrong, because hey, look, I am 1.7 meter, let's say I am just 2 meter. How many of me you should put on top of each other so that you get to the ceiling? That would be height of a classroom. If I'm 2 meter, then I'm going to place, well, in our classroom it's little taller, but my home is just 2 of me, so 4 meter. But I see places where the floor to the ceiling is 3 meter. So between 3 to 4 meter, doesn't matter. So I ask you to 3-story. If one classroom from floor to the rooftop to the ceiling is 3 meter, then 30 times 3 is 90. If it is our classroom, let's say that's 4 meter from bottom to top, then 30 times 4 is 120 meters. Okay, so it's between 90 to 120 meters. The option I gave you for number 9 is 10 raised to 0 meter, 10 raised to, this is 1, this is 2, 10 raised to 1 meter, 3, 10 raised to 2 meter, and 4, 10 raised to 3 meter. Look, this is 1000 meter, this is 100 meter, this is a 10 meter, this is 1 meter. There is no way. So this is x is less than 120 and greater than 90. So 30-story, and x is a 30-story building. So 30-story building is 90, between 90 meter to 120 meter. So it's not, definitely not 1 meter, definitely not 10 meter, and definitely not 1000 meter. So 100 is exactly fall between 90 to 120 meter. Problem 10 is order of magnitude, which is power of 10. Is directly came from your reference table. Every test, I'm going to make sure that one problem comes from the reference table. So you are forced to use reference table during the test. Okay, so problem number 10. Here's how we're going to do problem 10. It's very easy actually. Problem 10. I ask you, what is the differences between order of magnitude between the speed of light and the speed of sound? So this is speed of light, which is called c. This is 3 times 10 raised to 8 meter per second. And the speed of sound, which is 3.31 times 10 raised to 8, 10 raised to 2 meter per second. So you have a ratio, speed of light over speed of sound. Okay. So what is the ratio? 3 over 3.31 times 10 raised 1. You can write 10 raised to 8 times 10 raised to 2. So 3 divided by 3.31 times 10 raised to 8 minus 2. So 0.9 times 10 raised to 6. So 9 times 10 raised to 6, 10 raised to 5. So 9 is greater than 3.16. So 5 plus 1, which is 6. Why did I use 3.16? We explained that during our first, second, and third lessons when we went over order of magnitude. That has to do with square root of 10. I'm sure you remember it. Okay, that takes us to the next page, problem 11. You saw this problem on Wednesday, October 8, when you took the quiz 1. So I remember giving you this type of thing, problem 11. Graph is like this, VT graph. You need only 2 points, I don't know. This is probably 0, negative 10, I believe. And this is 1, 0. And this is 5, 40, I believe. Okay, and that's it. You connect them. Okay, so all you need to do, find the area. So this would be this would be this is between the x-axis and the graph itself, and this is above the x-axis and graph. So the blue minus green, make sure it doesn't go beyond below the x-axis and above the graph. It is stay within the triangle. Both of them are triangle. One of them is big, one of them is small. So the green minus blue, that's it. Okay, I'm taking my time because this is I like it. For me, this is like fun. Okay, so what do you want to do? You just write half BH, and you just write half BH. I believe this is 1, but check the test. So you're going to write green minus blue. So green minus blue is the answer. So what is the green? Let's do first green. Green is half. B is 5 minus 1, 4. H is 40. So the green is 80 meter. What is the blue? Blue is half BH. Half B is 1 minus 0, 1. H is negative 10. So the blue is negative 5. So this is negative 5. This is negative 5. And this is 80. All right, so now you know 80 minus negative 5, which is plus 75 meters. And that is the total displacement. The problem was easy, right? Problem 12, you saw it on Wednesday, October 8, and you've seen it today, but many of you told me that problem 12 is very confusing. Not sure why confusing. All you needed to do is draw a DT graph. I gave you the VT graph. If VT graph was confusing, then just draw a DT graph and then put them together, and then you'll see that VT graph gonna make more sense when you put it next to a DT graph. Let's see what I'm talking about. This is what I gave you actually. This is problem 12. I gave you a VT graph. This is T star when both car meet. I'm gonna change the color, and this is 15, and this is 20. Okay, I'm gonna, if this doesn't make sense, right, I call it area 1 and area 2, and the question was the car 1 when it meet with car 2, that is T star. Now I said that the car 1 whose area represented by car 1 when car 1 meet the car 2. Is it area 1? Is it area 2? Is it area 1 plus area 2? Or is it area 1 minus area 2? Okay, now let's put it in perspective by drawing a DT graph. So you have a displacement versus time graph. Now car one is moving car A. So this is car A. This one is car A. I'm going to use the blue for car A. Car A. So the car A moving with, so this is car A moving with 20t, right? The slope is steeper. However, car B has a head start 20 meter. This is car B. This is car B. This is car B. It has, because it gonna meet with car A only because it has a head start. Otherwise, it would never meet with car B because it's moving slower. So it has a head start, which is 15 meter. So it moves slowly, 15 meter. Okay, not too much, 15 meter. So it's moved slowly. It has a less steep. It's less steep. That's why this 15 is below 20. Okay, so then you're gonna write this is 15t. Car B is 15t. Of course, plus 20. So at t star they meet. So at t star you want to write 20t is equal to 15t plus 20. So 5t is equal to 20. So t is equal to 4. So t star is equal to 4. You already know this is the answer now by now. But to see it really, car A is the one that moves 80 meter, right? So 4 times 20, car A has to move 80 meters to meet with car B, which moves only 60 meters because it had the head start. So in order for the car A to move 80 meter, it had to be represented by area A and area B both, because only area A cannot give you 80 meter. Area A will give you how much? Only 60 meter. And that is car B. Car B only moves 60 meters. And area 2 gonna give you only 20 meters. Only 20 meters because total area is 80. Okay, so it has to be green and red both 80, because the car 1 had to move 80 meters in order to meet car 2, not 79, not 81, just 80. That's why it has to be area 1 and area 2. Area 1 itself is not going to be 80. Area 2 itself is not going to be 80. Area 1 plus area 2 is exactly 80. 13, you've seen this problem on Wednesday, October 8, and you saw it today again. So I asked you to find the slope of a line. I mean the equation of a line. The slope of a line is the same thing of a VT graph. Okay, so VT graph, so you know this is a first degree polynomial. You need to know only 1 point or 2 point. I don't know, which 2 point I give you? 3, 4, I guess. 3, 4. So call this one 3, 4. And there is a 6 and there is a, I believe, something like that. You don't need to know. Because, hey, the equation of the line, no matter how long the line is the same, because the slope of the line is the same. Okay, so this 2 point is more than enough for us to find the equation of this line. Okay, so first find the slope, 0, 0 and 3, 4. This is x, y, and this is the x1, y1, x2, y2. So 4 minus 0 and 3 minus 0. Okay, so y is equal to mx plus b. So y is equal to 4 over 3 t plus 0. So 4 over 3 t. So p of t is equal to 4 over 3 t. Of course, you could have used vf is equal to va plus at. Vf is equal to Vi plus At, right? A is 4 over 3. Initial velocity is 0, so Vf is equal to 4 over 3t. So there are many ways you can do the same thing, accomplish the equation of the line. And again, it doesn't matter how long the line is. If it is a line, first degree polynomial, it has one slope. And it has 1 degree. Once you find the slope, put a t and put a 1 degree. 14 to 20, again, you saw it on Wednesday, October 8. You've seen it today. Not sure whether it was easy or challenging. Anyway, let's go over. Okay, so let's first draw the dt graph that I gave you. I gave you 16 seconds. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 seconds, t is in second. Now I'm going to write the displacement. Displacement is in meter, okay? And the 5 is the peak. So 1, 2, 3, 4, and 5. Okay, so the first 2 seconds, there are 8 intervals, right? There are 8 sections. Each sections are 2 seconds long, and different thing happens at each section. So this one is at 0 to 2 seconds, the object moves 2 meters with constant velocity. Okay. From 2 to 4 seconds, object at rest. 2 to 4 seconds, object at rest. From 4 to 6 seconds, object speeds up, moves additional 2 meters. So 6, and from 2 to 4, all right. So this is going to go to 6, and this is going to go to 4. So object is speed up. Object is speed up, moves additional what? 2 meters. From 6 to 8 seconds, object is slow down and moves only 1 meter. Okay, so at 5 goes to 8, and 8 goes to 5. 5 goes to 8 goes to 5, 5 goes to 8. Okay, great. So now look what happened. This one has to slow down. No. Slow down. Has to be parabolic. Okay, slow down and 0. Okay, covering only the distance of 1 meter. Okay, and now it is speeding up and covering distance of -3 meters. Okay, so it is speeding up next 2 seconds. So from 8 to 10 seconds, it covers 3 meters. 3 meters means from 5 to 4 to 3 to 2. So these are the 3 meters. Okay, great. So it's gonna be 2. It's gonna be at 2. So 10 goes to 2, 2 goes to 10. Okay. So 10 goes to 2, 2 goes to 10. I'm not sure where exactly it is gonna be. All right. All right. Okay. All right. And the next 2 seconds, it slow down and moves only. When you slow down, you don't cover that much distance. So it covers only -1 meter, which is the displacement. So from 10 to 12, it covers just -1 meter. So you see 2 to 1, so it's just 1 meter. Okay, this goes to right here. I don't need it. Okay. Okay, so it's slow down. Okay. 12 to 14 is at rest. 12 to 14 is resting. And 14 to 16 is moved with constant velocity backward, covering only 1 meter. Okay, so we're gonna now divide and conquer. 8 sections we're gonna make. So you're going to call it velocity versus time graph. And I'm going to quickly make each section. Section 1. Every section is supposed to cross nicely. Section 2, Section 3, Section 4. It's supposed to cross 8, but Section 5, Section 6, Section 7, Section 8. Okay, great. We're going to call Section 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now let's find the, let's remind us something. It covers 2 meter here. It covers 2 meter here. It covers 0 meter. It covers 2 meter. It covers 1 meter. It covers -3 meter. It covers -1 meter, 0 meter, -1 meter. So let's check whether it comes over here. So displacement, final total displacement should be 0. So 5 over here. So 5 over there. So let's check. And also we need that. We need that to do our business. The business is, if this is a positive forward constant velocity, a diagonal line, this has to be a horizontal line. Okay, so this has to be a horizontal line. So this is 2 divided by 2, which is 1. So this is 1. Okay, the slope of this one is 0, which is easy. The slope of this one is, okay, the area, so this is a curve, so this must be a diagonal line which make a triangle. So the area of a triangle is half BH. Area is 2, base is 2, H. So